Just by way of demonstrating how clear and simple this method makes working out proportions, we'll use an amoxicillin suspension mix that's going into an 8 ml bottle. The proportion of the mix is 250 milligrams of amoxicillin to 5 ml of water. But we want to mix up a quantity using 8 ml of water, so what we have to work out is how much amoxicillin powder goes with 8 ml of water. The easiest way to work this out is to just simply cross multiply. Once we write it out with like terms over like, it's the equivalent of two equal fractions, because the ratio of the mix stays the same even though the quantities change. By looking at it as two equal fractions with an unknown on the bottom of one, it means we can cross multiply to bring the unknown to the top of the other side and everything else against it on the other side of the equals. So this is a very simple way of solving for the unknown. And because we know the unknown quantity is going to be in milligrams, we can lose all the signs until we come to the end. It just makes it simpler. To start, we'll bring the unknown to the top of the other side over the equals, and now we'll bring everything over to the other side of the equals against the unknown. Now to finish the calculation, 5 into itself goes once, 5 into 250 goes 50 times, and then 8 by 50 is 400. 400 over 1 is just 400, so the unknown equals 400. So just to look at where we started from, we had a question mark, and that answer is 400 and it's milligrams. By dividing the left hand side down, in this case by 50, you'll see clear why we can assume both sides as equal fractions. Here's what we've done again in fast forward. So if you give me about 3 minutes, I'll show you what I've done here. And this works also for more complicated calculations. I'll also go through speed, distance and time, currency conversions, and percentage population questions. Firstly though, I'm going to recap on this process again using a simple pancake mix of 20 grams flour to 90 ml of milk. But what if we only have 15 grams of flour? How much milk do we use? Just write it down like terms over like, flour under flour and milk under milk. Because we've written it down with like terms over like, and we know that the ratio stays the same, we therefore know that the unknown quantity will stay in proportion to the rest of the equation. This means we can treat it like two equal fractions and use cross multiplication to rearrange the equation so as we get the unknown on one side. So when the bottom number moves across the equal sign, it moves into the top position and gets multiplied by any number that's there already, and when the top number moves across the equal sign, it moves into the divide by position on the bottom. That's pretty much how it works. In the next section I'm going to show you the reasoning behind why it works. I'll move on then to a pharmacy preparation where we have weight to weight and volume to weight calculations to make. In terms of the overall percentage of the mix, you'll find once you write it out, like we've done already, keeping like terms over like, you'll find it's a very clear and straightforward way of working out the quantities needed. So, to explain why this method works, let's take a simple bread mix of 100 grams flour to 1000 milliliters of water. 100 to 1000 is the ratio, or 1 to 10 when you break it down. In order to stay true to this recipe, we're going to have to maintain this ratio or proportion, regardless of what quantities we use. If we want to use 40 grams of flour, we're going to have to use 400 ml of water. That's staying with the proportion of 1 to 10. Now, if you look at both sides more closely, you'll see that because we've used the same proportions, this is now the equivalent of two equal fractions. Here is an example of the method being used in a pharmacy calculation. We'll write percentage under percentage and volume under weight, so we keep like with like. Next, I want to take a quick look at other areas where we can apply cross multiplication. A fairly common one is speed, and we'll take it that it's kilometers an hour. Taking this statement, for simplicity's sake, we'll just change the kilometers into distance and the hour into time, so we're keeping like with like. Kilometer distance, hour time. Now we'll slide time underneath distance and we'll leave speed where it is, so now it is speed equals distance over time. So now you've got an easy way to call to mind the speed equals distance over time formula. Now we'll look at rearranging it for distance and time using the rules of cross multiplication. And the equals there shows that it's in balance, so one side is equal to the other. So now using the rules of cross multiplication, we're just going to move them around so as everything stays in balance, and we can find what the time and the distance is equal to. So speed is equal to distance divided by time. If we slide the time from the divide by position across the equal sign into the multiply by position, we'll see that speed multiplied by time is equal to distance. So the speed you're travelling at multiplied by the time you travelled for is equals to the distance you travelled. And next, if we slide the speed from the multiply by position across the equal sign to the divide by position down at the bottom, we can see that time is equal to distance divided by speed. So let's see how this works in practice. If a car travelled at 130 kilometers an hour for 3.5 hours, what is the average speed it travelled at? So we're given the distance it travelled and the length of time it travelled for, so we just need to find the speed it travelled. So the speed equals 130 kilometers and the time is 3.5 hours. So it's speed equals distance over time, or the distance divided by the number of hours he travelled for, will give us the miles per hour, or the kilometres per hour in this case, which is 37.14 kilometres. So we'll just go back to the start again, and this time we're given the speed, which is 37.14 kilometres per hour, and the length of time he travelled for, so we want to find out the distance. So firstly, let's rearrange the formula so we have the unknown quantity, that is distance, on one side of the equals on its own, and everything else stacked up equal to it on the other side. Speed is equal to distance over time. Slide the time over the equal sign, so we leave the distance on its own, and therefore we have speed multiplied by time equals distance. Now we pop in the values we know, do the calculation, and we see the distance travelled is 130 kilometers. So you'll see we can rearrange or manipulate the formula as long as we keep the whole thing balanced. Now we're going to use the same methods for a currency conversion. Then we're going to move on to a question where we're asked to calculate the percentage growth of a population from one year to another. Then we're going to look at the same question, but this time we're given the percentage growth and we're asked to calculate the actual population that this percentage represents. There are different methods of solving these problems like in the example here, but I find by laying it out like terms over like, the way we've done already, is a much more straightforward process. So simply write out the information you have, what amount is equal to what amount, keeping like terms over like, and cross multiply this information. We'll back it up for a second and break down what has actually happened here. The divide by 2000 moves across the equals and becomes a multiply by 2000, so it gets multiplied by 1. And on the other side, the x euro in the divide by position moves across the equals to the multiply by, and it's x euro multiplied by 1.36. And now in order to get the x euro on its own, we move the 1.36 across the equals to the divide by position. Now we're going to look at that population question where we're asked to find the percentage growth of a population from one year to another. This may look like a more complicated question because we're using big numbers, but once you lay it out in a very simple way, keeping like items over like and then cross multiplying that information to find the unknown on one side and everything else against it on the other. This is how we're going to solve this. We'll use the number it grows from as our 100% number because this is where it starts. And the number it grows to as our x% because we're asked to find the percentage growth. Because we started out at 100% and grew upwards, then this x% value here represents the 100% plus the percentage growth. So if we want to find out the percentage growth on its own, we just take away this from 100% or 100. Now we're going to look at the same problem again, but this time we're going to be given the percentage growth and we're asked to calculate the new population number from that.